Now let's continue with define and perform calculation using Dalton's law. Okay, Dalton's law states that the total pressure of a mixture of non-reacting gases is the sum of partial pressure exerted by each of the constituent gas in the mixture. Okay, then, since the gas molecules are far apart, so we can assume they behave independently. So the partial pressure of a gas is defined as the pressure exerted by a particular component of a mixture of gases. Okay, for example, if we have two gases here, so we have gas A and gas B. So this one, it will be named as partial pressure of gas A, partial pressure of gas B. And we are still using the same formula, that is PV equals to nRT to find the pressure. Okay, now let's move on. Okay, what do we mean by partial pressure? Okay, now for example, in a mixture, there are two types of gases. That is hydrogen gas and helium gases, and they are non-reacting gases. Okay, so inside here, okay, we will name that pressure of hydrogen. We say partially the container contains hydrogen gas. Partially, the container contains helium gas. So the pressure, we know that as partial pressure. Okay, so what is the total pressure, okay, of the pressure exerted by both gases? So we just need to total them up, okay? Now, next one, let's go for the calculation part. Okay, so for mixture of gases, so we have two types of gas. For example, we have gas A and gas B, and we use again same thing, PV equals to nRT. So we will get mole A and mole B. Okay, so the total pressure will be total mole of gases. Another one, we can use mole fraction. Okay, it expresses the ratio of the number of moles of one component to the number of moles of all components present. Okay, so for example, as we know, okay, if we have two gases, so we have A and B. So this one will be the mole fraction of A. Okay, so remember, no matter how many gas you have in the container, the total for the mole fraction will always be equals to 1. Now let's look at the example. Okay, now the question asks for determine the total pressure in mmHg, okay, millimeter mercury. Okay, and the partial pressure of argon and oxygen gas in the closed container, and also state the law use. Okay, state the law use. Okay, because we have two non-reacting gases. Okay, so we are using Dalton's law. Okay, next one, we have two gases, so we know that we need to find the total number of mole. Okay, and then what else is given? We have temperature given, so remember to change it to Kelvin, and then we also have volume given, but the volume given is in cm cube, so we must change it to liter as well. Okay, then after that we will get our answer in atm, but then change it to millimeter mercury as required by the question. Now next one, determine the total pressure again and the partial pressure. Okay, this one you can do it another way, because 3.7 gram and 7.5 gram means that we can just use number of mole. Okay, from here we can use the mole fraction. Okay, we can use the mole fraction for AR, mole fraction for oxygen gas. Okay, so there are two ways you can answer the question. Okay, Now this one I want to highlight a new one, that is two vessels which are connected by a valve. Okay, so before the valve is open, okay, when this is closed, so the number of mole of gas, okay, is confined to 0.5 liter only. Okay, so you get the number of mole. Then for gas, for neon gas, it is confined to 2.0 liter. Okay, then we get the number of mole. Okay, so we must remember the mole of gas before and after the valve is open remains the same. Okay, the only thing that changed is the volume. Okay, why do I say that the volume changed? Because the gas can travel to and fro between two vessels. Okay, when the valve is open. Therefore, we use total volume. Means the gas can travel in 0.5 liter. The gas also can travel in 2.0 liter. Okay, and then after that, since the question asks for mole fraction, okay, so we calculate mole fraction using the formula. Okay, and then we need to find total pressure after the valve is open. So we use total volume because after the valve is open. And remember, the mole remains the same. Means these two add up will still be the same. Okay, another one is collecting gases over water. Okay, when it is over water, okay, so we must know that, okay, first we have gas, another one is there is also water vapor inside. So means we have water vapor, okay, for example, we also have oxygen gas. So means that at this point, for example, at this point, the pressure is exerted by water vapor, the pressure is also exerted by oxygen gas. Okay, then why is it that we have ATM here? Because as we know from physics, okay, if this is the same point and then it is the same level, so means that the atmospheric pressure is the same as the total pressure of exerted by gas and also water vapor. Okay, so here you can see they use atmospheric pressure. If you do not want to use atmospheric pressure, you can always use total pressure equals to pressure of gas plus water vapor. Okay, so when you see the word displacement water method, or you see that when water vapor pressure is given, it indicates that this gas contains both. That is pressure of gas given and also water vapor. Okay, now let's look at one example. Okay, so you see here, it has already mentioned water displacement method. So means it hints that total pressure equals to gas plus vapor pressure, water vapor pressure. And you can see here as well, given water pressure of water vapor. Okay, so what we do is they need us to calculate the volume of oxygen in milliliter. Okay, so same thing, use PV equals to nRT. Okay, now find one by one what you need and then convert the unit into ml as required by the question. Okay, but only thing is, remember the pressure for oxygen gas, okay, it's not purely oxygen gas. Okay, it has water vapor. So you need to find out how much is the pressure of oxygen gas, not only the one that contain both. Okay, so now summary. We have learned Boyle's law, Charles' law, Avogadro's law, combined gas law, ideal gas equation, and also Dalton's law of partial pressure, which includes mole fraction. Okay, and don't forget, there's one more thing, that is, if it's collection over water, then we know that atmospheric pressure equals to P gas plus P water vapor. Okay, so that's all for all the gas law that we are learning for chapter